Have you ever looked at a roller coaster plummeting down a track or a skateboarder flying up a ramp and thought, how does that even work? What are the invisible forces at play? Well, guess what? It's not magic, it's physics. And today we're going to pull back the curtain on the unseen rules of motion and energy that control, well, pretty much everything. All right, so here's our mission briefing. First, we'll get our heads around the idea that motion is all about your point of view. Then we'll dig into the pushes and pulls that actually make things go. After that, we're going to talk about the two big types of energy, stored versus moving. And finally, we'll see how these two are in a constant dance, trading places all the time. So, first things first. Before we can really get into why things move, we kind of have to agree on what it even means for something to be moving in the first place. Okay, so let me ask you a question. Seriously, think about it for a second. Are you moving? Right now. I mean, you probably feel like you're sitting perfectly still, right? But is that really the whole picture? See, from your perspective, yeah, you're not moving. But if we could zoom all the way out, say to an astronaut floating in space, they'd see you on a planet that's spinning at 1,000 miles an hour and whipping around the sun at a mind-boggling 67,000 miles an hour. And the craziest part? Both of you are right. It totally depends on your point of view. This whole puzzle is solved with something scientists call a reference point. Motion isn't just a thing, it's always described in relation to something else. So compared to your chair, you're totally still. But compared to the sun, yeah, you're on the move. Okay, so motion is relative. Got it. But what's the thing that actually gets an object to start moving, or stop moving, or change direction? What's the secret ingredient? Well, it's all about pushes and pulls. And that push or pull has a name, force. You can think of it as the engine for any change in motion. Every time you kick a ball, open a fridge, or even just sit there, forces are all around you. And they're not random. They always have a specific strength and a specific direction. You know, it's just like a game of tug of war. If both teams are pulling with the exact same amount of oomph, that rope isn't going anywhere. Those are balanced forces. Nothing changes. But the second one team pulls just a little bit harder, that's an unbalanced force, and boom, the rope starts moving. That's the key to making things happen. And these forces are literally everywhere. Gravity is the force that's holding you in your seat right now. Friction is what eventually stops a car when you hit the brakes. And magnetism? Well, that's what's keeping those magnets stuck on your fridge. They are the invisible players in the game of motion. So we've got forces, the things that cause change. But what gives them the ability to do that? Where does the juice come from? For that, my friends, we have to talk about energy. Let's go back to that skateboarder. Picture them, right at the very top of a half pipe, just frozen for a second before they drop in. They're not moving, not yet, but you can feel it, right? You just know they're about to go. That feeling of about to happen, that's actually a type of energy. It's called potential energy. It's stored up energy, just waiting in the wings. For our skateboarder, all that potential comes from their position, how high up they are on that ramp. Thanks to gravity, the higher they go, the more of this stored energy they pack in. And here they go. They push off and are flying down the side of that ramp. All of that energy they had stored up is now being unleashed as the energy of pure motion. And this is kinetic energy. This is the energy that's actually doing stuff. As a skateboarder picks up speed, their kinetic energy skyrockets. When they're at the very bottom of the ramp, they're going as fast as they can, and that's when their kinetic energy is at its absolute maximum. So we've got potential energy that's stored and kinetic energy that's moving. But the really cool part, the secret sauce of it all, is how these two are connected. What really happens when something goes from being up high to moving really fast? This idea right here is everything. Energy doesn't just pop into existence out of nowhere, and it doesn't just vanish. It only changes from one type to another, or moves from one object to another. It's like the universe's ultimate recycling program. And a roller coaster is the perfect example of this. Think about it. At the very top of that first huge hill, the cart is just full of potential energy. Then, as it dives down, that potential energy gets traded in for kinetic energy. In other words, speed. At the bottom, it's all kinetic, moving super fast. And as it starts to climb the next hill, it trades that speed back in for height, turning kinetic energy back into potential. It's this beautiful constant back and forth trade. Which brings us right back to our skateboarder. After their run, they're coasting on the flat ground, and they eventually stop. We know a force, friction, is what stopped them. But wait a second. If energy can't be destroyed, what happened to all that kinetic energy they had? Where did it go? And answering that, well, that opens up a whole new world of physics.